This video goes over the Chapter 6 study guide. To review, we're going to be doing problems 15 through 26, 31 through 32, 34 through 37, 50 through 52, and 56 through 64. 15 asks us to find the measure of BE. We're told that BD is 75. So if the entire diagonal is 75, for a rhombus, the diagonals bisect each other. So we take 75 divided by 2, and the answer is 37.5. For number 16, we want to find the measure of AD. We're told that BC is 62.4. So opposite sides are congruent, and therefore, for 16, AD is also 62.4. For 17, just like BE, ED is going to be 37.5. For number 18, we want to figure out CDA here in blue. We're told originally that ABC is 79. So opposite angles are congruent, meaning CDA is also 79 degrees. To find the measure of angle BCD, we're going to take the supplement of 79. So we take 180 minus 79, and we get 101. And the same thing is true for the next one, 101 degrees. It is opposite BCD, or it's supplementary with the other angle next to it that's 79. For 21, in this parallelogram, WX is congruent to ZY. So we can set up the equation as b plus 6 is equal to 5b minus 8. So once we solve for b and get 3.5, we plug that back into WX, and we get 9.5 as our final answer. So for 22, we could plug in what b is into 5b minus 8 and figure out the answer. We could also just remember that opposite sides are congruent. So since WX is 9.5, YZ is also 9.5. For 23, to find the measure of angle W, we have to remember that consecutive angles are supplementary. So 6A plus 14A will equal 180. So if I solve for A, and I get 9, I plug that back in, and the answer becomes 54 degrees. To figure out the other angle, I can plug in A again, or I can just take 180 minus, and this gives me 126 degrees. So the measure of angle Y is going to be congruent to the measure of angle W, since they are opposite, and the measure of angle Z is going to be congruent to the measure of angle X, since they are opposite. So in 31, we're determining if the quadrilateral must be a parallelogram. So for 31, this one is actually a rectangle, because the diagonals bisect each other. So the answer would be yes, this is a parallelogram. In 32, if you consider this blue diagonal as a transversal, and these angles as alternate interior angles, you can conclude that one pair of opposite sides are parallel, and then a different pair of opposite sides are congruent. So no, this one is not a quadrilateral. The condition to be met was that the same side is both congruent and parallel, and as written, one side is congruent and the other side is parallel. Doesn't work. In 34, we know that CD is 18, and since CD is 18, AB is also 18. Then they tell us that CE is 19.8, so this other diagonal AE is also 19.8, and if I add these two together, I would get 39.6 for the total length of the diagonal. 36 asks about the other diagonal, and the diagonals are going to be congruent, so it's 39.6 again. And BE is going to be half of that, 19.8. For number 50, we are determining if the conclusion is valid or not, and this one is not valid. We did use as a shortcut that if the diagonals are perpendicular and congruent to each other, which these are, then you can conclude that a parallelogram is a square. The problem is we don't know that this is a parallelogram, so the rest doesn't work. 51 and 52 are both valid conclusions. So for number 56, if we start with the idea that this is a 90-degree angle because the diagonals bisect each other, and the given that VXY is 58 degrees, we can take 180 minus or even 90 minus to figure out this other angle. And then a property of kites is that this longer diagonal bisects that angle, so we can double it. So the measure of XYZ is 64 degrees. There's a 32 here and a 32 here that we add together. For 57, since ZWX is given as 50 degrees, To find ZWV rather, we just divide by 2, and this gives us 25 degrees. For 58, they ask about the measure of VZW. So that's going to be this angle over here. Since we just calculated the 25 and we know about the 90, we can take 90 minus 25 to identify the answer as 65 degrees. So far we figured out the 65 and the 58 here, and remember that they are equal across the way. So we can add together 65 plus 58, and 123 degrees is this last angle. Number 60 shows an isosceles trapezoid because the legs are the same and the bases are parallel, which means that 54 degrees here with angle T is congruent to 54 degrees here with angle S. And to find V and R, we figure out 180 minus 54, so 126 degrees for both of those missing spots. So to figure out 61, we know that an entire diagonal has a length of 121.6, and part of a diagonal is 70, so we subtract to figure out the missing part. And it turns out is 51.6. That goes right here. To figure out 62, we add the length of the two bases and we average them, and we get 48.5. 63, they tell us the mid-segment and the top base, and we have to calculate the bottom base. Since we are adding 0.4, I could add 0.4 again and figure out that it's 3.5. For 64, if this trapezoid was isosceles, then the base angles here would be equivalent. So to cancel out the squares, we first need to isolate n squared all by itself. So we're going to subtract 6n squared from both sides and add 11 to both sides, and we end up with this. So n squared is equal to 9 after we divide both sides, and we take the square root, and n is equal to plus or minus 3, and here it's just going to be 3.